Okay, let's move on to our next explanation. Let's work a little bit clear example of the chain rule, and let's continue with this topic. I think we're going to work with a couple of examples before moving to implicit derivation or differentiation. And in this example, I am splicing or splitting the chain rule in its components. If we are using or applying the chain rule, we work from outside to the inside. And as you know, at the beginning of this subject, I emphasized the use of the composite functions. So if you remember, we have those two functions, f of x and g of x, and we tried several ways and several manners to compose that two functions. In one way, f um, composite function of g, g composite function of f, f composite function of f, g composite function of g, and so far and so on. And one thing that we need to have clear is that there is not only composite functions of two functions. So we can have a composite functions of 3, 4, 5, or more functions. And in this case, the procedure is the same. Is some kind of cascading the relation between the functions and the evaluation of each one of them evaluated in the outer function of each one of them. In this case, I'm explaining here, for example, we have this dx, which is the derivative, and we have an outer function, which is this f function, and there's another inner function here, this is g of x, and we are evaluating the outer function, which is the f. We are evaluating the f at the inner function. So this is the procedure that we already know. So when someone asks us to differentiate this composite function, then the procedure that is equal to the derivative of the outer function, which is this f, the outer function, and once we have or get this derivative of the outer function, we are going to add the inner part because we are evaluating the derivative of the outer part at the inner function. So we are going to let the g of x as it is, but we are going to add the derivative of the outer function here. And once we have these two components, we are going to multiply. This is multiply. Multiply by the derivative of the inner function. So is the derivative of the outer part evaluated at the inner part, and then times the derivative of the inner part. So I expect in this case, now it's more clear for all of you how to calculate or identify the way that we can work this composite functions differentiation. Let's work an example. Let be y equals the sine of x to the square. As you know, here we have two functions. We have the trig function, which is the sine, and we have the x to the square, which is another function. This is a square. This is a power function for x, and we are evaluating this inner part with the sine trigonometric function. So this when we see this kind of arrangements, and somebody asks us to find the derivative of this, we can now, in this case, apply the chain rule. So once we find this dy dx, we have that y is equal to the outer function, which is the sin, and the inner function is the x to the square. Therefore, the chain rule gives us the following result. Dy dx equals the derivative of the outer function, which is the derivative of the sine, and we are going to evaluate the derivative of the outer function in the inner function. So we're going to keep x to the square like it is, but we are going to differentiate the outer part. Okay, so if we work this derivative applying the chain rule, then we come up with the cosine, which the cosine is the derivative of the sine. The cosine of x to the square, because we are going to keep this inner function and the same here. So we're going to have the cosine of x to the square times the derivative of the inner part, which is the derivative of x to the square is 2x. So the result for this is 2x, which is this inner part, 2x times the cosine, which is the derivative of the outer function, evaluated at inner function. So it's 2x times the cosine of x to the square. And this is the result applying the chain rule to this function. Okay, I'm expecting now that you have now a more clear understanding of what the chain rule is, and it works when we have um, two functions, one evaluated in the inner part of the other. And please recall that this is not applicable to the product of functions. So you have f of x times g of x, then we need to apply another method, which is the method for product of functions. But in this case, we are evaluating this inner part, and this is a function, and we are evaluating this with the sine of the trigonometric function. So this is a composite function. We are applying the x to the square, and this is giving a result by itself. And the result of this, we are evaluating the result of x to the square, applying the sine function. So that's the meaning of this chain rule. Okay. So if you have any comments or questions, please let me know. You have my phone number. If you need it, you can ask for it. Maybe you can send that message via classroom or email. I will be aware pending to answer your questions. Stay safe.